Hey everyone, today we're going to create a cool rolling cube. Let's dive right in. Right-click in your content browser, go to Input, and select Input Action. Let's name this IA_input direction. Open IA_input direction. We need to set its value type to Axis 2D. Now, create a new input mapping context and name it IMC. Let's configure the inputs inside the IMC. For the A key, add a trigger pressed. Add modifier swizzle input axis, and then negate. For the D key, add trigger pressed. Add modifier swizzle input axis. For the W key, add trigger pressed. For the S key, add trigger pressed. Add modifier negate. Alright, with the input set up, let's create our controllable cube. Right-click in the content browser, select Blueprint class, and choose Pawn as the parent class. Name it BP_rolling cube. Open BP_rolling cube. In the Components panel, click Add and search for Cube. Drag the cube component onto the default scene root to replace it. This makes our cube the root component of the pawn. Let's also add an arrow component. This can be helpful for visualizing the forward direction of our cube during development. Untick Hidden in Game in its Details panel so we can see it while playing. Event Begin Play and search for Get Controller. From the return value of Get Controller, drag out and search for Cast to Player Controller. We need this to access the Enhanced Input subsystem. Add Mapping Context node. Select our IMC. Let's make our cube respond to the inputs. Right-click and search for our input action, IA_input direction. Select the event for it. Let's create a new variable to store this input. Create vector variable, name it as input direction. Using action value X and Y set to input direction. Let's test that. Place the BP_rolling cube in your level at 0, 0, 0. Set auto possess player to player 0. Hit play. You'll see the input direction is now working, but we need a camera. Set up a simple camera actor. Create a new actor blueprint and name it BP_camera. Add a camera component and set it as the root. In Event Begin Play, use Get Player Controller node. Add Set View Target with Blend, with target set to the player controller, and New View Target set to Self. Place this camera actor into your level. Now play the game again, and the view should switch to your new camera. Back in BP_rolling cube. Create a vector variable named pivot point. Use the cube component get component bounds. Use the input direction and multiply it by the box extent. Add the result to the origin to find the rolling edge. Subtract the Z component so the pivot is at the bottom edge. Reconstruct the vector with updated Z and set it as the pivot point. Use Draw Debug box to visualize it if needed. This helps make sure the pivot is calculated correctly. Let's test it. Now it finds pivot point on the edge of the cube correctly. Create the following variables: axis rotation, vector, target rotation, rotator. Use rotate vector around axis node to calculate the axis rotation. Use input direction variable plug into in vector. Then set angle degree 90 and axis C to 1. Use combined rotator node to calculate target rotation. Use input direction Y multiply 90 then set to X roll. Using input direction X multiply minute 1, then multiply by 90, then set to Y pitch. Let's create the variables we'll need to animate the roll smoothly. Create a Boolean variable, name it rolling. A float variable, name it rotation speed. A float variable, name it current angle. A float variable, name it delta angle. Set rotation speed to 200. In event tick, first, add a branch to check if rolling is true. If rolling is true, get rotation speed, multiply it by world delta seconds and set delta angle to this value. Create another branch node. The condition is current angle greater than 90. If current angle greater than 90, set rolling variable to false. Set current angle variable to 0. Use set actor rotation node to set the final target rotation. If current angle greater than 90 false, create set actor location and rotation node. Use current angle add with delta angle variable, then update to current angle variable. To calculate new location, get the current actor location. Subtract the pivot point from the actor location. This gives us a vector from the pivot to the cube's current center. Use the rotate vector around axis node. Use axis rotation variable plug into axis and delta angle variable into angle degree. Add the pivot point back to the rotated vector. This is the new location of the cube. To calculate new rotation, create combine rotators node. Plug get actor rotation node into A and our rotator from rotate vector around axis output into B. Let's test it. It's not working. I think I forgot to trigger the rolling variable. Let's go back to the IA input direction event. Add a branch node and check the condition with the rolling variable. If rolling is false, then set rolling to true. Now it's working. Let's try scaling the size of the cube. It still works. Thanks for watching.